Much for being so good at time. We're going to move on from the green bit to the smart bit next. So we're going to be talking about competitive, connected and automated waterborne transport. You can't hear, it's not plugged in. I'm not shouting enough, that better. Thank you all for being so well behaved and coming back from coffee so promptly. I appreciate that. We're going to move on to talk about competitive, connected and automated waterborne transport. But before we do that, I've just got a bit of a public announcement to make. There's been a couple of mobile phones located in the bathrooms. So we have them just outside the door. If you have lost or misplaced a mobile phone, we've got a couple out there, but we're not going to tell you what they look like because I don't want to, set up a trade in dodgy mobile phones. So let's start, if everybody's comfortable. And we're going to kick off this presentation, the series of presentations. There are going to be 3 initial interventions, and then again, like we did this morning, some overviews of projects that have been carried out within this context of the smart, connected, competitive, automated piece of the day's events. So can I start off by inviting Fontini Yiandou, Head of Maritime. I don't know how I did with your name, Fontini, but thank you very much. And she's going to talk to us about the work that DG Move are doing in this space. So thank you. Over to you, Fontini.
Thank you very much, Diane. Can you hear me?
Yes, we can.
Okay, great. Good morning to all of you. Many thanks for the invitation to open this panel on competitive, connected and automated waterborne transport. And many thanks to the organizers. Now, it's clear that shipping is a big need of transformation, and this transformation has started, but clearly we need to be to put more efforts to meet the targets of decarbonizing shipping by 2050, but also to make this mode of transport more safe and secure and smarter. The overarching policy document on our side, on DG Move, we are using is the Sustainable and Smart Mobility Strategy that sets the frame for transport and maritime transport as well to become safer, sustainable, and more efficient. Now, what this political vision entails, what it says is that in order to achieve these objectives for transport, we need to work along 3 axes. First of all, we need to make all transport modes more sustainable. Second, we need to give sustainable alternatives in a multimodal logistics system so that the most sustainable modes are privileged. And last but not least, we need to put in place incentives so that this transition and this change can occur. We have set very clear goals when it comes to waterborne transport in particular, and those are that we want to see short sea shipping and inland waterways to increase the traffic by 25% in the horizon of 2030 and by 50% in the horizon 2050. And the question is, of course, how to do it and how to do it in a sustainable way. But before coming to the house, I'd like to highlight 2 important messages for us. The first one is that we firmly believe that competitive, connected, and automated waterborne transport should never be achieved at the cost of maritime safety. We are now working in further enhancing the maritime safety aspects by revising our core legislations, and proposals are going to come soon. This will include also digitalization aspect and how we can better profit of this. The second message is that we should never forget that enhanced maritime safety means also cleaner oceans, because by avoiding accidents, we avoid oil pollution, we avoid plastics pollution or fishing gear pollution. So we should not forget that. Now, coming to the house, I'd like to say that for us, both digitalization and automation, and of course, alternative propulsion are part of the reply to the challenges maritime transport is facing. Digitalization is, of course, one of the big priorities for this commission. And the spectrum of digital applications is very large, spanning from design and building to integration of systems and, of course, into operations. There are many applications already out there, from fleet optimization to real-time management to enhanced automation and autonomy, thriving too. And all these are examples, but what we would like to see and what we are trying to see is the development towards a system of systems approach. And this applies both to the ship, but also to the communications between the ship and the shore. And in today's presentations, we have the competitive and connected aspects of our strategy presented by two projects, the Holy Ship project and the Novimar one, and the automated one that will be presented by the AutoShip. We should not also forget that the challenges posed by digitalization and automation are not only on the ship side, but this theme poses also enormous challenges for administrations that have to approve and verify their capacity of flag states, and they have also to be monitoring maritime traffic as coastal states. Coming now to the autonomous, automated autonomous ships, the so-called MAS aspects. We have had a lot of discussion around this, and in the past years, there has been some kind of overpromise of what these technologies could bring. On the other side, what we see is that ship owners are less interested in that, and they are more focusing on the decarbonization side. We think, the Commission side, that none of these approaches is correct. We believe that we need to be realistic in what can be achieved in the coming years. Of course, we need to assist the technology to develop. We need to maintain our technological edge as Europeans. And when we are speaking of technology, we don't speak only of decarbonization, but also of automation and autonomous ships. Now, it's not very clear whether we will see one day fully autonomous unmanned ships because there will be many, many hoops to jump before we reach there. But there are plenty on the digital side. There are plenty of things happening already. There are plenty of applications that are there to enhance safety of navigation, port call optimization. This is in the making. So that part is already there. When coming to the autonomous side, what we believe is that we will first see the higher levels of automation on the short sea shipping segment, on the feeder segment, and on inland waterways navigation. At least this is the conclusion we have reached at the second MAS summit we have organized 1 year ago. But what is even more important is to bear in mind that autonomy should be there to solve shipping problems of today, improve safety, decongest ports, improve the inland logistics chain, and help shipping become greener. And that's why we think that we should not look at the ship side only, because this will not make a big difference, but we need to look at the whole logistics value chain, to look at mooring, to look at ports, the transshipment, and of course, to look at the documents that are going to help through the electronic transmission maritime to become more efficient. There are also other challenges that are going to be posed by the fact that we will have mixed traffic for many, many years between conventional and more autonomous ships. What is important in this, and this is very dear to us, is that we should be working in establishing the safety assessments in a rigorous and timely manner, because all these trials have to happen in a safe way. And for this reason, we have worked with member states to establish operational guidelines for trials and tests at sea, so that such trials can be done in a safe manner, and that we can reap the benefits and go to the regulatory process in the right way. And that's why also we are asking all research projects to have such safety assessments, in particular those that are going to give an outcome to the regulatory process. And our European Maritime Safety Agency is now developing a risk-based assessment tool in order to provide risk assessment analysis and model to support administrations and industry when assessing these technologies. Of course, everything will be integrated in our EU mass trials and test guidelines. This, the output of the work of EMSA, but of course, any other relevant output we get from research projects. When it comes to regulation, the International Maritime Organization has started some time ago the development of the regulatory process, at least the identification of what needs to be done. But this might take some years before it becomes a reality. What is important in the meantime is that we have a proper frame so that all tests and trials are done, as I said, in a safe and orderly manner, because from the day we have an accident, all confidence in the system will be eroded, and this is certainly not something we would like to see. I'd like to close by making a call. I think that what is important in this challenging development is to have full collaboration, full cooperation among the European actors and not competition. We believe that the Waterborne technology platform is the right place where such exchange can take place. And the exchange should be not only on the EU-funded projects and trials, like the ones that we are going to witness today, and we believe these are very timely and could be giving direct input to policy developments at EU and IMO. But the exchange should also cover nationally funded projects in industrial trials, and also this exchange should be connected with international developments. For us, this exchange will create trust, and therefore we will be able to contribute to the change of the mindset of all, from consumers to shippers and to ship owners. Of course, I have not dealt with all the many exciting aspects of this development. There are many horizontal aspects that we need to look at, like the liability or the impact on staff and crew, but this is a longer discussion. I'd like to conclude by inviting us all to reflect how we would address the issue that even if automation and digitalization seems to bring many, many benefits, it's still very hard to sell to the shipping industry. So this is something that we will need also to address if we want to make this a reality. Thank you very much.
Thank you. Thank you, Fontini. That was really interesting and a great reflection at the end, which I'm going to transfer to the comments later on, or to the comments and questions, so thank you for that. So now we're going to, thank you very much, we're going to move on to Antoine Kidzyetzky, who's the Policy Officer at DG Grow, who is going to talk again about this competitive, connected and automated, the smart aspect of our agenda today in waterborne transport. So over to you, Antoine.
Many thanks, and indeed I will try to complement what has been already said by giving further thoughts to this important aspects of digitalization and competitiveness for waterborne transport. If you allow me, maybe I will start where Fontini ended, with the importance of collaboration, because indeed digitalization represents a challenge, but also an opportunity, and that goes beyond what we may see for the operators. It concerns the entire maritime cluster. It is about also technology providers, ports, and for this, in order to be a success, it's clear that that cooperation is essential. And in order to foster cooperation, it's clear that research and innovation can be a very attractive and powerful tool. The simple fact that we're having this discussion today is a first demonstration of that. We've heard also about, in general, the development of the Waterborne technology platform, but also it was very interesting to already hear from the first panel in the different projects to see how much different actors were going together to develop those solutions. And I think it is also important to see that for a number of those solutions, the actors that need to be involved need to also be outside the traditional, if I can call it like this, the traditional maritime sector. We've heard in the previous panel about getting also the energy suppliers on board, but in here, if we were to make a parallel with the work on digitalization, it is also about getting the know-how and the expertise from the IT industry to try also seeing whether synergies could be explored with other sectors that had to actually deal with the transition towards a higher degree of digitalization. Actually, this cooperative approach is very important in one of the exercise that DG Grow has recently launched with the transition pathway for the mobility ecosystem. That activity was initiated by the updated industrial strategy, which we published last year. And we identify as one of the follow-up of the strategy, the fact that we should develop transition pathway for the ecosystem that are most affected by greening and the digital transition. So the idea behind the exercise is to provide a bottom-up assessment of the costs and opportunities of the green transition in the different industrial ecosystem. We've launched the work for the mobility ecosystem, which covers automotive, rail, and waterborne transport. We've launched the work last week on the 24th, 2 weeks ago now, on the 24th of January. And I would like to invite all interested stakeholders and parties and participants today to look at DG Grow's website, to look at the document we've published as a staff working document outlining scenarios for the transition, but also to really participate in the consultation that we have launched. And interestingly as well, we've put the 3 objectives of greening, digitalization, and last but not least, as we talk about it as well, competitiveness and resilience as the 3 main objectives. And we also touch upon issues like cross-cutting issues like skills and financing. in this exercise, we fully recognize the fact that digitalizing the mobility ecosystem could have a major impact on its competitiveness. I think we heard it already from Jaap in his presentation earlier about the importance that further innovation can have on making the industry more competitive. This is clearly fully recognized by us. Digitalization is a way to meet industries or market demand for new products and services. We heard about automated, or higher degree of automation or higher degree of connectivity. And here also maybe just to remind what Magda Kopczynska was saying earlier about the importance and the EU leadership in this field. I think this is also when we talk about the competitiveness, I think it's also another element to take into account. So there is the issue of the market demand for new services, and there is also the issue of accelerating the transition, and there it could be through the development of new mobility services, improved routing, etc. So the spectrum of application is very wide. I mean, we heard that already, but I would just like to maybe highlight a couple of elements where higher degree of digitalization could help either on market services or market demand, or for the transition could help actually the entire maritime cluster to stay more competitive. Maybe one of the first elements I would like to mention is single window, because we heard about it earlier as a passing reference. But maybe just to recall that for short sea shipping and boosting short sea shipping, reporting formality and the simplification of reporting formalities was very often highlighted as one of the key elements. And actually, what do we see now is that the proposed solution for the simplification of reporting formality goes hand in hand with a higher degree of digitalization through the European Maritime Single Window environment. So I think this is also interesting to see how a digital solution can then very much help the entire sector altogether to be more competitive and to also gain maybe some market share. Another example that we heard about, and I think Fotini mentioned it briefly, the issue of port call optimization. That could mean for the future improved routing, allowing operator to optimize the sailing to reach the port, which would mean then in turn reducing fuel consumption, ultimately reducing emissions. So where we see as well that the train transition really goes hand in hand, they go together. But we see as well in the small video that was showcased, at least for people joining online, the small video on the different projects, the importance that new solutions for instance, maneuvering in port, auto mooring, auto docking could have. There is a lot of potential there for new product services that could be a win-win altogether. But indeed, as I said earlier, the benefits are not limited to the operations, and there is a great potential for the supply industry as well, either when it comes to the design of ships or the equipment itself. And here, maybe just a few elements that I could, on the top of my head, that I could mention is the points of predictive maintenance, digital twins, etc. There again, when we talk about win-win, I think this is extremely important, because what could represent a win for maybe the yards or the equipment manufacturer through better planning means as well that better planning can also be transferred to the operator, which means reducing the immobilization of the vessels for the intervention, and ultimately the benefit is much larger. Going smarter means also more complex equipment, more complex ships. That as such is a way to be more competitive, because there is a know-how behind, which means that it's a way of differentiating itself. So I come back here to the issue of research and innovation as a way of making the industry more competitive. I think this is really a point where it is important. We heard already earlier by previous speaker about the international dimension of technology development. I think it is very important that we remain really in the group of leaders on that. But when it means complex ships, complex equipment, or more complex building, we also need to keep in mind then the importance of adjusting the skills and of upskilling, reskilling, and training for the staff, either on the side of the production, the supply, but also on the operators. Of course, much more work is still needed to fully embrace the challenge of digitalization and also the opportunities. Fotini, I think, provided a very good overview and left a lot of food for thoughts and point of reflection of what was necessary. And I would like to come back really to what we have identified on our side for the transition pathway. The way we are looking at the different challenges and the different objectives through the transition pathway is with research and innovation, technology and infrastructure deployment, the regulatory framework and the standards, and then the skills. And I think some of the points I mentioned in my brief intervention now, you will see that all those boxes are sort of ticked, and they are important, and it's important that we actually progress on all of them. I will leave you with that for reflection. Also very much looking forward to hear from the project and what was happening on the ground. And I would also leave you with the invitation to really join the effort, this collective co-creation effort that we are launching for the transition pathway. Because it is important that we also hear from you what you see are the challenges, what you see are the possible solutions, and how we best work together to make sure that this can actually be delivered to facilitate the twin transition for the mobility ecosystem, including the waterborne transport. Many thanks.
Thank you, Antoine. That was really fascinating and thought-provoking. So that's really helpful. We'll come back and answer some questions. We're going to think collectively together about some of these issues that are coming up after we've heard from Georgios, who did tell me how to pronounce his name a couple of times. Charalampous. How did I do? He didn't answer. Who's from CINEA and is going to talk to us about some relevant projects that have been conducted under H2020. So I'm grateful. Thank you very much.
Thank you very much, Diane. I know it will be a challenging day for you to pronounce all these Greek names. But, okay, we will all manage. So thank you very much. I'm Georgios Charalampous. I'm a project officer at CINEA, being in the Waterborne sector. And before starting, I would like to highlight how privileged we are in CINEA to be close to the projects, to see how they develop, to see their added value, their achievements, their perspective, and potential to deliver, at the end, what is expected towards the Green Deal objectives. Jumping into the projects in the area of competitive, connected and automated waterborne transport, we have clustered under this umbrella the three key thematic areas that were already presented by Dick Bakers this morning. In the areas of infrastructure, of new and improved waterborne concepts, and innovative shipbuilding and complex value-added specialized vessels. This is a portfolio of 29 projects with an overall EU contribution of 250 million euros. And with a rather impressive 475 beneficiaries participating in these projects. Going into the challenge of each one of these thematic areas, starting with infrastructure, there's a cornerstone for the decarbonization of shipping, because no matter which would be the improvements on the level of the vessels, we need the infrastructure to provide the green services that the vessel needs. So the main challenges that were addressed in the Horizon 2020 calls for the infrastructure project were the integration of the ports into the logistics chains, to optimize passenger and freight flows for a low emission mobility, to accelerate the deployment of sustainable alternative fuels and electromobility, and then to be able to replicate these solutions overall in Europe, because there is a very dense port network, so the objective is also to replicate these solutions all around Europe. Checking into more details the portfolio of infrastructure, we can find here 6 projects that mainly answered to 2 main calls. The first one was the Port of the Future with 4 projects, mainly aiming to green and smart multimodal logistics operations and re-engineering of port processes. Digitalization, that you heard a lot from Antoine earlier. And the 2, let's say, flagships in infrastructure, the European Green Deal call, with the 2 main projects on green airports and ports as multimodal hubs, where there are demonstrators to deliver low-emission supply production of systems and storage of alternative fuels, electromobility in the ports of Europe. Answering also the question made earlier to Gabriel concerning inland waterways. In these projects, you can find also inland waterways ports. It was actually a requirement for the European Green Deal topic to include at least one inland port. So there are no inland or maritime. There were topics that were asking for interventions in both inland waterways and maritime links. Jumping into the improved waterborne transport concepts, there we can find the main challenges of autonomous ships. The improved logistics operations, but not only at the level of the port, but at the level of the service. To deliver the improved system and waterborne operations, and some blue growth project that we have in our portfolio, aiming at autonomous vehicles for undersea operations. So these were all translated into topics, receiving a portfolio in the end of 12 projects. On the left side of the slide, you can see the blue growth project. So Maribe was exploring the opportunities to invest in blue economy. The 3 projects, Bridges, Dextrov, and Endurance, were projects that developed unmanned and autonomous vehicles for undersea operations. A very nice cluster for improving logistics services, with 4 projects, 2 of them mainly aiming to the maritime logistics, and 2 of them dedicated to inland waterways. So again, it was a topic that asked for inland waterways logistics. And the autonomous ship, that you will hear later on more details on the project results. And new and improved transport concepts in waterborne transport, with Project Novmar, the vessel train concept. Marco will give you more details. And gas vessel, that was an innovative approach to transport CNG. The third thematic area that we have included under this umbrella of competitive and connected waterborne transport are the innovative shipbuilding, another very, very competitive area, global competition in shipbuilding. So through the topics of Horizon 2020, we try to have projects to improve the competitiveness of the shipbuilding industry in Europe, to involve also SMEs. So the main challenges that were addressed in these topics were the research in new materials, to validate modular standardized shipbuilding concepts, to increase the professional skills in the shipyards around Europe, and also to explore the possibilities from innovative ship designs. In this thematic area, we have 11 projects, so ship lease and holy ship. Again, you will hear more details later on innovative ship design and the optimization of the life cycle. 2 blue growth projects on the development of specialized vessels for onshore and coastal activities. The development and production and use of high-performance lightweight materials in shipbuilding. Modular development of vessels with 3 projects, Tram, Navice, and High Seas. And a very dedicated topic on shipbuilding for the improvement of the processes, Mari for yards, Resurgam, and Fiber for yards. This is in a nutshell the portfolio of CINEA in these 3 key thematic areas. And before closing, I said in the beginning that we are proud at CINEA to be close to the project and to see and feel the results. But at the end, this is not the point that we at CINEA get on the results. The point is that the project disseminate the results to the stakeholders, to the market, so that people in Europe know what is going on in the market. We understand what is out there, which is the state of the art and the way forward. So again, I always have this discussion with the project whenever we are in reviews and kickoffs, that please focus also on your dissemination. We know we are very busy with the development, but also you should not neglect this aspect of the implementation. Go out there, show your results, and create your exploitation pathways. On the other hand, because I know that we have a lot of people participating now online, seeing this, watching this conference. So we have clustered the project so you can find perhaps projects that are in your interest. So go into the websites, check their social media. There are further events. So this is a very good opportunity, but unfortunately we don't have enough time to demonstrate all the results. So go and look for the results. There could be something there for all the participants, for all of you. And for the future, I would like to remind that we have 6 open calls in Horizon Europe. 2 of them are again under the umbrella of the competitive, connected and automated waterborne transport. The first one is on computational tools for shipbuilding. And the second one is for the autonomous feeder loop services. Again, maybe to prevent one question, there is an indication that inland waterways are also included in this topic. So check the specificities of the topic and you are welcome to submit your proposals. Thank you very much. That's all from my side.
Thank you. So that's a really helpful overview. Thank you. You stay up here because we might ask you some questions later, if you don't mind. Now I want to focus in on the projects themselves, where we can get a little bit more depth and granularity about what was done and who did it. So we're going to start off with Autoship, which focused on connected inland short sea vessels and was really about effecting a modal shift. So let me hand over now to another name missing. So sorry about that. Hello.
Yeah, hello. Hello, Lolo. This is Marco Monica from Italy, actually, from Pioneer Consultants. I'm the coordinator of the Autoship project.
Thank you, Marco. Well, you're very welcome, and we're looking forward to hearing about the Autoship project. So over to you. Thanks very much. Thanks.
So I believe you have my presentation on the screen, right? Because I can't. Yes, thank you. Okay. So we can, thanks everyone. I would have liked really much to be there, but I hope that I will manage to give a good glimpse of the project starting now. Okay, so if we can go to the first slide. What I'm happy to see is that actually listening to who spoke before me, basically the project is pretty much aligned with the general objective. So I'm starting my presentation looking at what is at stake with the maritime industry, right? And I think so I won't belong on this because we have already discussed this. So the maritime industry is actually remarkably important for the business, let's say, and the life worldwide with logistics. We have seen what happens if just one ship blocks the Suez Canal some months ago. On top of that, unfortunately, the business is the technology is a little bit old in many ways, so it needs a renewal because there is a lot of traffic and there are a lot of emissions and air pollutants, so there are a lot of environment at stake. Not only that, there is also some social aspect because if we look at the workers' condition, of course, they must be safe, but also, let's say, by nature, the maritime work has historically been, let's say, not the best way to have a settled life in some cases, right? So we can improve those conditions. Then we have the necessity as Europe to also switch from road to ship. So we are looking for modal shift. And in this transition, which may be very expensive and let's say complicated, but we need to keep an eye and valorize our EU technology leadership, with otherwise, in a way or in another, we risk that it moves towards other markets, for example, Asia. So we can go to next slide. We can see that what is at stake actually when we talk about autonomy is that autonomy is not a goal by itself. So this is not the way we see that, but it is an enabler of improving different conditions absolutely in a sustainable way. So I try to make a list which is quite general, but gives you the idea. So first of all, it can prevent human mistake. So this doesn't mean that humans are not in the loop anymore, absolutely. Then it can improve also life quality because in the autonomy concept, there is the concept of controlling the ship. Let's say controlling the ship from remote and another aspect that can make actually the seafarer's life in a way better if we sustainable integrated technology in what is the value chain today. But then, of course, autonomy, depending on the business case and which segment we are discussing, allows to redesign a little bit the system at ship level, at an integrated system level. When I say a ship level, I mean that, for example, in some sector where inland waterways, for example, you may easily have less accommodation space, which turns into more cargo. But also, if you see it on a more larger view, you have smaller and more flexible vessels which can move differently from smaller ports. So the overall system and network can be changed. All in all, you have a better fleet management control, which turns to be, let's say, and allow better energy management, which you also improve with your, with new technologies that are on board. So you have a system which is more resilient, which can really support the sustainability of the shipping and can give new possibilities to sectors that otherwise would be not in a dead end, but at least we can say that are quite old and need renewal. So if we go to the next slide, I try to present the entangled perspective that is of this concept in the easiest way that I could. So you see, there are a lot of things because people think that autonomy is just about technology, but that's not like that. There is not a direct fight in between the autonomy, for example, and greener vessels, because the two things can really support one the other. Despite this, of course, at this moment, the shipping industry may be still a little bit skeptical. So we are aware of that. And if we go to the next slide, maybe to the next slide, this means that there's still a risk for industry and risk for investors, right? If we go to the next, this risk are basically three types of risk. So long time for international legislation to come out, so uncertainty from that perspective, safety risk and requirement that of course must be proven, ships must be proven to be safe. And then of course, residual technology risk. If you don't test the technology, you don't know if it works, but, and so you see it's a chicken egg problems that we are trying to solve. If we go to the next slide, let's say that auto ship is can we go to the next slide, please? Okay, Yes, thank you, thank you. Okay, so AutoShip as a project, let's say it is was designed to bridge a little bit the missing gap. So the project was started in 2019 and is now more or less at its month 32. We have still at least one year ahead. I put the question mark because of course we are also affected from COVID, so it may last longer. But the key concept of AutoShip is that it has a lot of objectives, but they can be divided into two branches. So developing and enabling technologies and testing them, and then build the common visions, which is all around the technology. If we go to the next slide, I can also briefly introduce who is the partnership of AutoShip. So it's a very, I would say, Norwegian project, meaning that the key technology provider is Kongsberg Maritime, which is participating with three companies of the group. Actually, in the beginning, we had also Rolls-Royce. So it was kind of the cooperation or competition in between competitors, but Rolls-Royce turned into Kongsberg Maritime. And then we have Syntev Ocean and Strathclyde University, which are leading in the, not only let's say, in the business cases analysis and regulation analysis. And then we have Bureau Veritas Transfer Liabilities. So we have quite a diverse partnership. Also the Vlaamse, which is the Flemish authorities, which has given us a great hand in communicating, for example, with the CCNR on the inland waterway. And then, of course, we have two ship owners. And then we can go to the next slide. And going back to the ship owners, one key characteristics of AutoShip is that we have the ambition of having two remote and autonomous vessel demonstration here. So one on the inland waterways and one on the short sea feed carriers. So they are quite different business cases and as technologies, but they share in common. And so, for example, in this slide, I only wanted to focus on the different autonomy level that you may see on the inland waterway part. So the class 2 pallet shoulder barge. You will have that the perspective is to have it constrained autonomous and continuously unmanned operation. While if you see on the short sea operation, you will see that the aim is having periodically unmanned bridge and high degree of automatic operations. On the next slide. And in terms of demonstrations, we have quite a hard challenge in between us because we are having two. One is the inland waterways on the right. So we are, let's say, sailing around Antwerp, I can say, but in the Flemish region. So we are, let's say, cooperating with the view of the Belgian regulation, the Belgian authorities. While on the other hand, on the short sea shipping, we will end up with the 70 nautical miles from port to port demonstration from Denmark to Norway. Next slide, please. In terms of technologies, you need to develop a huge package of key enabling technologies. So to make it very simple, you need to have the best technology on the vessel, the technology on the shore to support the vessel, and then you have the communication infrastructure, which is something with the rest of the world, which is quite a huge set of technologies. Generically, what we're doing is that we are developing this system. We will showing that they're safe, and then we are developing a proved concept of operation. Next slide, please. Generally speaking, again, I try to give a map, but it's very complicated. You could say that on the ship, we have what we call artificial or digital, depending on the case, captain and engineer. So that the system has the control of the route of the navigation, working according to maritime rules, not to have collisions, of course, and to understand what others can do also on the sea. And then you have the control what is happening inside the ship. So everything really related to alert, asset and energy management and predictive maintenance in order to be able to tell who outside what's happening on the ship. And next slide, please. As I said, we are also looking at outside the technology. So from definition of the logistics supply chain, analysis of regulation and liabilities analysis, deep dive with socioeconomic aspects. So we will deliver cost benefit analysis for the two use cases, definition of the training frameworks, what happens to the workers where a shore control system are to be developed, what kind of skills they have to work there, or and how the world of work should change to allow a sustainable transition with these two different or integrated work and new job position. And then we have the ambition to use these results to propose very important external stakeholders to use our results. And next slide, please. So I try to give a very short and to the point where we are, or perspective of where we are. So we are now at the point after 2 years and 2.5 years that we have been developing key enabling technologies. So cameras, integrated sensor, and algorithms of artificial intelligence to make it in the simplest possible way. We are working a lot on communication and cybersecurity, and the keywords here is redundancy, because you have different systems for different distances. So you cannot have just one. We have developed concept of operation, which are now to be over on the inland waterways, while we are finalizing the one on the short sea. We are developing the simulators to allow this and speed up all the process. We are studying the ergonomics and design of the shore control centers and the system on board. And then we are also developing support tool decision, which includes ship design, which includes fleet design, fleet management, and will allow the cost-benefit analysis for the ship owners and for also decision maker in general. Next slide, please. Then we have a lot of set of all the results, which I left the link in the presentation. Everything is quite public and is downloadable in this. So we have a good framework of public deliverables, which covers supply chain mapping and modeling, design standards, gap and compliance analysis, security and safety analysis, and business case. And in general, when the results are even confidential for the consortium, we have a lot of publication, more or less are still on the website. So I invite you to go there and download them. That can give you a deeper picture of topics that are a little bit more, let's say, confidential to the consortium. And then we can go to the next slide. Also, since dissemination is important, I fully agree with Georgios. We had quite a remarkable impact on public opinion and on communication in general. So we delivered diversified strategies to dissemination, hackathon, design competition, podcast, and interviews. And we were to the BBC, or better, the BBC invited us, which was quite a good for us. We have complete stakeholders and innovators analysis and survey. We are cooperating a lot with other projects in the domain, especially Aegis and Moses on the short shipping and, let's say, smart port domain. And we have a lot of attention to public discussion and opinion, also on the social, because it's important. We have remarkable followers on LinkedIn, more than 1,000, which is quite unique, I think, for a European project at this level. We are directly dialoguing with an advisory board, but also with EMSA, for example, and with the ISO. So we have made a proposal and we are working actively on terminology related to autonomous ship system, thanks to the work in AutoShip. And then some, next slide, please. I just want to finish with some consideration. I try to highlight the most important here. So first of all, R&D, up to now, let's say at least one year ago, if you have the scenario, you can see that there are two threads. One thread is autonomous shipping, and the other head is a little bit smart port and logistics. But of course, you need to put together the two in the next generation project. It is what is needed, because there is no autonomous shipping unless you have a good business case and with ports and logistic operators, or it's on the shore. There is not one unique business case, so it may be very different from, for example, inland waterways and the short sea shipping, different ship and completely different characteristics, retrofit and new builds. They are different stuff. And because of this, there are not one set of technology players. So what you can see looking at the market, there are not only giants, for example, Carlsberg, which is in our project, but for other segment, different business cases, you have different smaller technology operators and also startups that are, let's say, entering into the business. The last point, public opinion is quite essential, because the next step is to make it accepted. So a lot of attention must be given to not pass the wrong messages and about the sustainability of the autonomous ship business and technology. And so these are my main points. Next for motorship, this will be a very intense year. So we are going to get ready for the final demonstration, hopefully very sooner, let's say, acceptable time. We'll be able also to invite some of you maybe to our demonstration. We are, for example, delivering an R&D roadmap, so a study of the condition and gap of R&D, and we are making quite an effort on that at the moment, and also cost-benefit analysis and socioeconomics analysis, which will bring a little bit all together for all ship owner and decision maker, and we hope that these will be very useful for the future. So thank you. This is all I intended. I hope that I was not too fast or not too, let's say, crowded in information. But this is all for me. Thank you.
Thank you very much. That was Marco Colello. Having a digital problem with my phone at the moment, I've been unable to communicate with my colleagues digitally, which is why I've had to call upon people to come and give me bits of paper. So that's not a very good start for the digital conversation, but that might be to do with the functionality of the old woman who's running it. Anyway, let's move on. Let's think about Holy Ship next. Our presentation today will come from Jochen Marzi, who is going to talk about Holy Ship, which is going to be really interesting. It's about life cycle and holistic design throughout the life cycle. So thank you very much. Over to you, Jochen.
Thank you very much, Diane, for the kind introduction. Ladies and gentlemen, welcome to the Holy Ship presentation at the Waterborne Transport Workshop. I'm very grateful to the organizers for giving me the opportunity to present holistic optimization of ship design and operation for life cycle. Next slide, please, during this event. Holy Ship as a project set out in 2016 as a Horizon 2020 project to address the challenges of future ship design. Next slide, please. The starting point for considerations leading to the Holy Ship project was the constantly rising requirements for ships and other maritime assets over time. Complexity of products, compliance with rules, regulations, call for advanced analysis to be included already in early design stages. And this in turn calls for advanced and innovative design methods. Consequently, the main objective of the project was to integrate all relevant design disciplines, not only design but also operational, in a platform or set of platforms which can be used during the different design stages, while at the same time considering life cycle cost and environmental impact, as well as technically and regulatory constraints. At the end of the project had to deliver a set of homogeneous and integrated software platforms for all design phases, including optimization for the entire life cycle of the product, plus virtual testing. Or, as on the next slide, to rephrase it, tomorrow's advanced ships need advanced design tools, and next please, Holy Ship did create those tools required to design tomorrow's ships better, more efficient, and with less environmental impact. Next slide, please. This huge undertaking was supported by a large team of about 40 partners from industry, software developers, research, and academia. And of course, there have been some fluctuations over time during the project, as it is so big, but we managed to keep the consortium together and achieve the planned results. Next, please. What are now these achievements? We have a set of three main project results. The first one being the development of a complete new design concept supporting the holistic approach. The second main result is the integration of complex simulation tools and the use of surrogate models, which play an important role during optimization. And finally, it is a set of 9 different and very complex application cases in which the use of tools and platforms has been illustrated. To go a little bit more detail into details on the next slide, for the design synthesis, we have abandoned the traditional design spiral used in shipbuilding in favor of an integrated systems approach to ship design. And this design synthesis concept integrates all design disciplines in a modular and concurrent way, which can be extended further also in the future, in view of future requirements arising over time. All modules or design disciplines can interact at any time, and it is this interaction which provides an increased level of design information, detail, combined with continuous consistency checks. This concept allows to treat a much larger design space than would have been possible with traditional methods. This already is the second model, second achievement, the surrogate models which are used during the optimization. These are prescribed response surfaces and the tools used to to predict, for instance, changes in hull forms, CFD models, and the cases model platform, which you're using here at the center, provides the necessary basis to predict those and to use them in during the design stages. On the next slide, we have the 9 application cases that we treated in Holy Ship. These are selected from typical industrial design tasks, and thus covering more or less the ground of maritime design. We have a complex OSV case, a PAX case with lightweight superstructure elements in there, a research vessel focusing on installation and life cycle costing analysis, a concept design for a multi-purpose ocean vessel, 2 different merchant vessel cases. The first one addressing retrofit and operational changes to container vessels and bulk carriers. The second one demonstrating a virtual testing capability of the Holy Spec RCE platform, which is also part of the environment. And then we have a seventh case, which is an offshore platform, a gravity-based platform in shallow water, just to illustrate also that we go beyond ships. And the final 2 cases are again ships, a Robux vessel and a double-ended ferry. And all 40 partners were involved in these application cases over time. Next, please. To illustrate that in a little more detail, I have selected 2 examples from our range. The first one is a Robux ferry for operation in the Mediterranean. And this case focuses on the evaluation of different advanced propulsion concepts, podded propulsion, different fuel solutions. And the optimization includes hydrostatics, hydrodynamics, machinery, structure, and cost. And the objective here is, of course, to find the most suitable, sustainable, and the greenest solution. Illustrated on the next slide, please. This figure, which has been used throughout the project in different instances, illustrates the design process applied and the different design disciplines and their tools which were applied. The platform, here it is cases in the middle, integrates a number of different analysis tools for several types of hydrodynamic analysis, for instance, as well as necessary stability, energy simulation, structural analysis, and cost. The tools used in this case were provided by 7 different project partners and directly linked to the platform as a basis for the concept and contract design, which performs the necessary optimization based on goal functions. In the same way, other tools can, of course, be integrated. On the next slide, we put some, as mentioned before, we put some emphasis on the energy efficiency in this case. Saving energy is a first and important step towards improved environmental compatibility. As a reminder, every ton of fuel not spent during operation means about 3.7 tons less CO2 in the atmosphere. This holds, of course, for HFO, but also e-fuels and others will significantly benefit from savings, not least in terms of cost. Energy efficiency is determined during the design of a new ship, and hydrodynamics play an important role, as indicated in the comparison of the power curve on the left for different designs. The optimized vessel in this case consumes up to 15% less power for certain operation points. But of course, hydrodynamics are not the only factor that needs to be considered. Today's, and even more so tomorrow's ships and other maritime products are subject to a huge set of requirements which must be taken into account already during the design. On the next slide, we have illustrated here what has been achieved with all the elements considered in our design study. The net present value has been increased substantially by around 3 million euros compared with the starting point, and the optimization yields an average of 8.5% power and hence fuel savings over the entire operational profile, which also considers a number of situations which are not do not achieve the full 50% of savings mentioned before. But this alone translates into 1,745 tons of fuel saved per annum by an optimized ship, which is quite substantial, as you can imagine. And the corresponding CO2 savings are impressive as well. And this, of course, must be seen also at fleet level, and we believe that this result clearly highlights what holistic design, analysis, and optimization can achieve to render shipping more energy efficient and greener. On the next slide, I have a second example for a smaller double-ended car and passenger ferry for operating in the Finnish archipelago. Sailing in this case is much shorter than the previous case, but it highlights a special situation, the comparison of a conventional, that is a diesel engine propulsion ferry, and a purely electric propulsion concept using batteries. On the next slide, we indicate in the same way as before that we're using 8 different design tools for this application case. Of course, necessary hydrostatics, stability and dynamics. There's also energy simulation, structures, including weight and cost, and the analysis of the electric propulsion concept. Next, please. During the initial design exploration, 2 candidates have been identified as potential optimal solutions, varying in length and breadth, but comparable in net present value, which has been chosen as the goal function for this optimization. In a second round of more detailed analysis for the 2 candidates, this resulted in slight modifications of the 2 configurations, came up with the further optimized longer vessel as being the winner in this competition. On the next slide, there's one more shedding highlights on certain results which have been obtained during this optimization and the elements that have been considered. And there's, besides the traditional form propulsion optimization, this is especially also a look into the performance of the battery, which has been considered and which played an important role as the operation had to be looked in, that we had to look into the different settings for winter and summer operations. So that already leads me to the conclusions of the project. On the next slide, over the duration of 4 years, Holy Ship has developed a design synthesis and integration of software tools that has been realized by a combined top-down and bottom-up approach. Next, please. More than 40 different design tools or exploitable results from different partners have been integrated into the platforms that we developed. These were applied and demonstrated in 9 different design cases, and the concept has clearly added a new quality to ship design. The flexibility of this concept allows for future extensions and meet also the requirements of the next generation of ships. An important element in the project was also the development of those surrogate models mentioned before, which replaced time-consuming numerical simulations during the optimization cycles, as this paved the way to efficiently include also complex analysis in the process, which in turn helped to achieve better results. On the next, please. The whole story of Holy Ship, which is very briefly presented here, is well documented in 2 volumes of the Holy Book, as we call it, which has been compiled and edited by Professor Papanicolaou, published by Springer last year. During this short summary presentation, I touched only on a few aspects of the project, but next, please. In addition to the book, there's also a lot more information available from the project website, including also recordings of more complete presentations given during our public workshops and conferences. And I would like to end on the next slide, please. We're adding a quick outlook at follow-up activities. Towards the end of the project, we devised the idea of a common marketplace for ship design tools and services on the basis of our developments in Holy Ship. The idea behind this is the provision of affordable and well-maintained tools for the industry, for first-time customers as well as regulars, and for any size of projects. In addition, we also expect the marketplace to form a platform in the future for research and to be used by academia. A first prototype has been set up already during the late stages of the project, and a larger number of project partners are presently exploring opportunities also in Horizon Europe to continue and finalize this work in the near future. With this, we expect to contribute twofold: to an improved competitiveness of the European shipbuilding and design, and to an improved environmental compatibility of ships in the future, and thus provide a major building block of the overall goal of zero-emission waterborne transport. That's it from me. Thank you very much. I have a last slide as well, giving you the once again the details of the project website, which you can consult for further information as well. Thank you.
Thank you very much indeed. Bye-bye. Thank you for that presentation. That's really helpful. We need to crack on and go now straight over to Marco Scholtens, who's going to talk to us about Novamar. So thank you, Marco. Nice to see you.
Yes, thank you very much, Diane. I'll try to leave some time for questions. So I'll try to be brief. Yeah, thank you very much. The Novamar project, we just got to the finish line last November. On this slide you can find some general information about the project, which ran from 2017 until November last year. So if I'm still sweating, it's because I just finished the final reporting towards CINEA. And we had our final report meeting, and we can conclude that we are all very happy with the results the project achieved. The Novamar project was run by a total of 22 partners, which is for research and innovation action actually quite a lot of this scope. And on the next slide you will see all these partners, and most of them have their main track record in inland shipping, although the project also paid significant attention to seagoing applications as well. However, the focus was on inland shipping, and fortunately not just the research and technology providers were involved, but we also find several logistic and ship-owning companies who provided an input to the project to keep the whole concept of the vessel train close to the ground, so to say. So what's the whole idea of the Novamar project? And the strategic aim, and you will hear me say logistics a lot, is to improve the logistic situation on inland waterways by creating vessel trains with a lead ship and follower vessels, which are controlled from the lead vessel, and in that way lead to a better utilization of inland waterways. And it can do so in several ways. It can do so by making the operation more efficient, by requiring less crew to be on board the vessels on average. And secondly, by allowing vessels to be loaded in a more optimal way to create more point-to-point traffic, rather than many ships having to call at several ports to discharge, for example, containers. And in that way you can reduce the amount of miles an individual ship is sailing. So it's mainly a logistical change, and you have to adjust your logistical system to make this work. Now, quite some research was needed, and that research was partly in evaluating how those logistic systems would work and what the benefits or disadvantages of such system would be. But obviously quite some technology is needed to make this vessel train work in a technical sense. And for the cargo planning and handling, because a key success factor would be that you use the vessel train to create more point-to-point traffic, you also need to find new ways to organize your traffic loading and discharging, so also your port operations are affected by this vessel train. So quite a diverse range of topics to study. Now, all these research topics could be translated into a number of key results we aim to achieve. And as I said, we're happy to report that all these key results were achieved. I will not go down all 9 of them, also given the limited time we have available today. But I'll highlight a few key results here. First of all is to create a new waterborne transport system. And for that, a significant amount of logistical analysis through discrete simulations and with realistic input from these operators was performed to see in which areas the vessel train could provide a not only credible but also beneficial solution to the logistic challenges we have in inland shipping. And we found that this was also the biggest sticking point, that the main benefits could be achieved in areas where there is very high traffic density. To compose these vessel trains and let them sail, to make it beneficial, you need a longer train. So a train of 2 vessels will not be beneficial. You're not making significant savings. So you will need a longer train. And to get that longer train composed in a reasonable amount of time, so ships don't have to wait at terminals, you need to deploy them in an area where there's high intensity traffic. So the Rhine corridor was basically the most beneficial area in which we could deploy the vessel train and still get a profit from it, mainly because there's so much traffic that you will not incur tremendous waiting times before a next vessel train can depart. So service frequency will be the key there. Now, to make that happen, we don't have to automate to the extent that, for example, you saw on the AutoShip project, which is on a technical sense much more ambitious than the Novimar project was. But the good thing there is that this vessel train can also be applied using existing ships with relatively minor modifications. And that was also demonstrated in the project demonstrator. And in the image here you see a picture of the actual vessel demonstrator, which was held in the Haringvliet in the Netherlands, where a small vessel train with big ships was formed on inland waters, and the lead vessel successfully controlled the trajectory of the following vessel. Basically, a train was formed by having the follower vessel forming a digital link and following the lead vessel around a series of maneuvers, going under bridges, and ultimately a full 180-degree turn, where we showed that the follower vessel could really follow in the footsteps of the lead vessel. And that was a very successful demonstrator, although it was quite a road to get there. And I think that was an important highlight, that demonstrators in these kinds of projects create a sense of urgency, or to ensure that all the technology which is being developed is not just great in a lab, but also showing that it's working in a real environment. And that helps a great deal in achieving the credibility. And we saw a great change also in the market, which was very skeptical up until the point around the vessel train, I don't know. But showing it on the water, showing it in reality, helped a lot. And of course, still critical questions can and should be asked on whether this vessel train concept will work in practice. But the effect of a demonstrator like this, showing a successful demonstrator, helped a great deal in showing, well, there's questions to be asked, but it works. So that was a great achievement. And also, a lot of the technology needed to get to this demonstrator has led to commercial products already. Their track control systems were not developed for the purpose of the vessel train, but track control systems were improved and additional functionality was added to this track control systems, which now can be used by commercial clients and are being used by commercial clients. So it's the partial technologies which are also finding their own way into the market. A similar example, and then I'll stop listing examples, is Covadam, which has a real-time depth measurement on the river, which was required to improve the usability of the vessel train. And Covadam is, I've lost count on how many vessels they've installed their software. They're providing real-time water depth advice. And that's really helping the inland shippers to optimize the cargo loading, because they know exactly how deep their vessel will be in the water, whether they can pass on the bridges, whether they have enough water under the keel to safely navigate with the maximum amount of cargo. And that's creating the efficiencies, loading your vessels to the maximum efficiency. I spoke previously about changing the way in which vessels are loaded and discharged, and that was dealt with in a separate work package which looked at alternative ways of cargo handling in the vessel train. And together with partners, we looked at how can we optimize the loading and discharging of vessels to a point where there's minimum transshipment and maximum point-to-point traffic, also in smaller inland terminals, which don't have an abundance of gantry cranes by which to do it. So these kinds of cargo moving units on wheels rather than cranes, also with the matching vessel designs which could utilize these kinds of technologies, were developed. And they could be used in a vessel train, but could also be used in other solutions than a vessel train, where there's a lack of infrastructure and your logistics system, especially on the Danube, which is not very suitable for vessel trains, offers great potential for the use of these types of vessels and cargo handling systems. Now, yes.
Running out of time for questions.
Yes.
I'd like to take one if we could. Thank you.
All the results, which were far too many to describe in 10 minutes, are logged in a vessel train handbook rather than a physical book. It's an online repository where all the results are introduced by the work package leaders and then matched by all the reports, presentations, which were created in the project. And that will continue to be available to the interested audiences. Now, final on some exploitation potential challenges. As I said, the business case will be most likely for vessel trains will likely be limited to high traffic areas, and it's also quite possible that the advent of autonomous shipping will make the business case of this vessel train outdated by the time it would be ready for the market. Which is on the one hand a shame, but on the other hand, all the partial results we achieved in the meanwhile, which I tried to highlight, does result in the fact that all the project partners are actually very pleased with the project results achieved, because so many of the technological steps and the logistical insights they gained throughout the project have helped them greatly in their day-to-day business or their follow-up research. So for me, a key takeaway for this project would be is that the technology innovation programs, on the one hand, should be rooted in a mostly logistical necessity to apply the technology. But even if that particular logistic use case is not, in the end, the solution for your problem, do not forget all the achievements you picked up along the way on your voyage to that destination. Thank you very much.
Thank you. Thank you very much. Thank you, Marco. So we're obviously running very, very close to time. I know we need to go and get lunch. I want one question and one question only, and it's coming from Paul Kemp, who asks us, the panel, I think, for potential autonomous passenger vessels, how would emergency situations such as fire and evacuation be managed? Which I think would actually segue us quite nicely into the session after lunch. But have either of you got anything you'd like to say about the risk of passenger management on an autonomous vessel? Safety risk. Go for it.
Yes, obviously, if we look at the advent of where autonomous ships will be implemented, the start is with the smaller ships. We see commercially the drones, the unmanned ships appearing in the market, and now research projects are delving into cargo ships. But uncrewed passenger ships, especially sea-going passenger ships, that's really a long term before the technology is A, mature to handle those risks, B, before it's cost effective. I mean, by their nature, computers are good at routine and people are good at emergencies. And in handling emergency situations, properly trained crew will, for quite some time, be superior in their response to computers. So we will see a growing use of autonomous technologies on ships and a growing number of ship types which can operate safely without crew on board. But I think passenger ships are pretty much in the back of the line there.
Brilliant. Okay, well that's absolutely fantastic.
May I complement?
Yes, please do.
Yes, so as also Fatima mentioned at the beginning, so safe waterborne transport is also a priority. We also had a respective topic that is now under evaluation for navigational accidents, avoidance, and container ship fires. So issues of safety are tackled there and related also to the autonomous vessels.
So that's absolutely fantastic. I think what I want to say here is that this is evolutionary, as it was this morning. We're moving forward. And I think what we've seen from this segment is everybody's been really good at dissemination. So I'm sorry we didn't have time for questions as much as I would have liked. Go online, check out the projects that are online, check out the information, and whilst you have lunch, you'll have access to some of these people and you can talk amongst yourselves. And I think the key question that we wanted to answer was, why is it so hard for shipping to adopt digital? So go think about that whilst you're having your lunch. Thank you very much. 2:15, if you could, be back here. Thank you.